A is this 2 cross 2 matrix. If sum of the diagonal elements of A raised to 13, this is 3 raised to n, then we have to find the value of n. Now, in most of the resources, you will find that for calculating the trace of this matrix A raised to 13, sum of diagonal elements is nothing but the trace of the matrix. So, for finding trace of A raised to 13, they will multiply this matrix A. First, they will calculate A squared, then A raised to 4, A raised to 8, and so on. And then they will calculate the sum of diagonal elements. But there is another much easier method of solving these type of problem. And in last few years in JEE Main, you will find that there are a number of PYQ where some matrix is given, and you have to find sum of diagonal elements of that matrix raised to some large power like 13, 15, and so on. So these type of problems one can easily solve if you are familiar with the concept of eigenvalues of a matrix and properties of eigenvalues. Right, first we'll talk about what is eigenvalues of a matrix. We already know about characteristic equation, right? We learned about characteristic equation of a matrix in Cayley-Hamilton theorem. So from there we can find eigenvalues of a matrix. And then there are few properties of eigenvalue that you should know. So then these type of problems you can solve within few seconds. So basically eigenvalues are nothing but they are but roots of characteristic equation of a matrix. And what is characteristic equation? Determinant of A minus lambda equals to 0. So that means from diagonal elements, we subtract lambda and then equate the determinant to 0. So from there, we get a polynomial equation in lambda. For 2 cross 2, we'll get quadratic equation. For 3 cross 3, we'll get cubic equation and so on. So that equation is called characteristic equation of the matrix. And the root of this characteristic equation, they are called eigenvalues, right? Also for 2 cross 2 matrix, there is one direct formula also to write characteristic equation, lambda square minus trace of A into lambda plus determinant of A, this equals to 0. Using this formula in one line, you can write the characteristic equation of any 2 cross 2 matrix. And the root of this characteristic equation, they are called the eigenvalues of the matrix, right? So let us say for this quadratic equation, the roots are lambda 1 and lambda 2. So these lambda 1 and lambda 2, they are eigenvalues of this matrix A. Now, there are few properties of eigenvalue that you should know. The very first property is that if you multiply the eigenvalues of a matrix, then you will get determinant of the matrix, right? Product of eigenvalue, this is always determinant of A, which is obvious from here also. For this quadratic, product of root lambda 1 and lambda 2, that will be determinant of A. Similarly, if you find the sum of eigenvalues, right, if you calculate the sum of eigenvalues of a matrix, I'm writing for 2 cross 2, but this is valid for any general n cross n matrix. So product of eigenvalue, this is determinant of the matrix, and sum of eigenvalue, this is nothing but trace of matrix, right? So these are the two most frequently used properties. And for solving such type of problem where you need trace of A raised to n, there is one more property that you should know, and that is for a matrix A, if the eigenvalues are lambda 1 and lambda 2, again I'm writing for 2 cross 2, but valid for any general n cross n matrix, then for A raised to n, the eigenvalues are lambda 1 raised to n and lambda 2 raised to n. Now, this is very important result because for suppose if I know eigenvalue of matrix A, they are lambda 1, lambda 2. So for A square, it will be lambda 1 square, lambda 2 square. For A cube, lambda 1 cube, lambda 2 cube, and so on. So here what we'll do is we'll find the eigenvalues of matrix A, and then for A, let us say for matrix A, the eigenvalues were lambda 1, lambda 2. So what should be eigenvalues of A raised to 13? This will be lambda 1 raised to 13 and lambda 2 raised to 13. That will be eigenvalue of this matrix A raised to 13. And then the trace of this matrix A raised to 13, that will be nothing but sum of the eigenvalues, right? So that means lambda 1 raised to 13 plus lambda 2 raised to 13. So that will be the sequence of steps. First find the eigenvalues of matrix A. From there find the eigenvalues of A raised to 13. And then the trace of matrix A raised to 13, that is nothing but sum of eigenvalues. So here if I have to find eigenvalues of matrix A, then it will be lambda square minus trace of matrix A. So for matrix A, trace means sum of the diagonal elements. So that will be 2 plus 1, 3. right? So lambda square minus 3 lambda plus determinant is also 3. So this is the characteristic equation for matrix A, right? For matrix A, the characteristic equation using that standard formula is lambda square minus 3 lambda plus 3 equals to 0. And now let us try to find the roots of this equation. So clearly you can see that for this equation, the discriminant is negative. So therefore we'll get imaginary roots. The roots will be minus b plus minus root over b square minus 4ac and that divided by 2a, right? So that means one of the eigenvalue, this is 1 by 2 we can take outside. So one of the eigenvalues is 3 plus root 3 iota and the other eigenvalue lambda 2, this is 3 minus root 3 iota. These are the two eigenvalues of matrix A. So now trace of this matrix A raised to 13, this will be nothing but sum of eigenvalues of A raised to 13. And for A raised to 13, eigenvalues are lambda 1 raised to 13 and lambda 2 raised to 13. So now basically we have to calculate this sum and then we'll get trace of matrix A raised to 13. Also this is given as 3 raised to n. So by comparing, we'll find the value of n. Now, in most of the problems, you will get simple eigenvalues, right? Simple integers, but here we are getting a complex number. So if I have to calculate any large power of a complex number, then we know that we have to express that complex number in polar form or Euler's form and then use the De Moivre's theorem, right? So if I say that this complex number, let us say lambda 1, this I'm representing as Z1. So this is 3 by 2 plus root 3 iota by 2. So now how to write this complex number in polar form or Euler form? So for that we need the modulus and the argument of this complex number. Now modulus of this complex number will be 9 by 4 plus 3 by 4, that is 12 by 4. So root over 3, right? So modulus is root over 3 and the argument is uh, 1 by root 3, so that will be 30 degrees. So that means argument is pi by 6. So the first complex number in Euler form, this will be root 3 e iota pi by 6, this raised to 13. And the second one is conjugate of this one. So that means root 3 e minus iota pi by 6 and this raised to 13. Now root 3 raised to 13, with this we can take common. And then you have e iota 13 pi by 6 and plus the other one will be e iota in fact, e raised to minus iota and then we have 13 pi by 6. Now 13 pi by 6, this we can write as 2 pi plus pi by 6. 2 pi we can remove pi by 6. So cos pi by 6 plus iota sin pi by 6 and from here the imaginary part will cancel. So basically you will get 2 into, in fact this number outside, this was root 3 raised to 13 and here you will get 2 into cos pi by 6 because the iota sine pi by 6, that term will cancel with this conjugate, right? And the real part you will get twice. So cos pi by 6 root 3 by 2, that means ultimately this is root 13 raised to 13 into root 3. That means 3 raised to 7. So from here clearly you can see that value of n, this will be nothing but 7, right? So using this concept of eigenvalues, one can very easily solve this problem. And there are multiple PYQ in JEE Main as well as in JEE Advanced, where using this concept of eigenvalue within few lines, you can solve these type of problems. So for that, just remember these three properties. First of all, eigenvalues, they are roots of characteristic equation. For 2 cross 2 matrix, this is the standard formula to write characteristic equation. Sum of eigenvalues trace, product of eigenvalues determinant, and for a raised to n, the eigenvalues are lambda 1 raised to n, lambda 2 raised to n. So first we calculated eigenvalues of matrix A. Then from there we got eigenvalues of a raised to 13 and then trace of this a raised to 13. This is nothing but sum of the eigenvalues. Ultimately this trace was 3 raised to 7. So therefore the value of n, this will be 7 and that is the correct answer for this problem.